Greetings and welcome, friends. So yesterday we were talking about like parallel lines cut by a transversal, and we discovered some theorems, right? Where we were able to prove things about angles formed by those parallel lines and transversal, where we said, right, if the lines are parallel, then, right, consecutive angles are, corresponding angles were congruent, or alternate interior angles were congruent, or alternate exterior angles were congruent, or consecutive interior angles were supplementary. Today, we're doing the converse. I was going to say opposite, and then I got all scared, and that's not what it is. Not the inverse. It's a converse day, where today, notice this, it says if two lines are cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. So we are proving parallel lines by knowing congruence of angles. All right? That's the work that we're doing today. Yesterday, we knew the lines were parallel, and we were proving the angles were congruent. So this one, instead of cat, will be called CAC, right? CAC, corresponding angles, converse. And let's use the corresponding angles converse. It says find the value of x that makes parallel to okay. Question: is this a stretch or a question? Oh, whoa, slow down. So, all right, tell me how to solve it. I appreciate it. All right, so we're going to try to make these congruent, and that's going to happen when these measures are equal. And now what do I do? I'm not a fan of that line, but you can pretend it's there. Like, oh man, I didn't even. Oh man, I can't even. There we go. All right, so 3x equals 60. Yeah, div 3. X equals 20. And so if x is 20, then these are both 65, and they are congruent. And then, by the corresponding angles converse, I would be able to say that m is parallel to n. Wop, right? So that's the idea. Today, we are proving the lines parallel. Where yesterday we were doing... I keep wanting to say opposite, but it's not a true opposite, is it? No, it is not. Oh, wow. I like this one. Monitoring progress, question 1. I don't always do these, but I like these. All right. Is there enough information in the diagram to prove that these are parallel lines? Oh, or other things that you could prove about it. What could I show? Yeah. Okay, all right, you're going. I got you. Corresponding angles. Oh, wait a minute. Wait a minute. Okay, these are corresponding. I don't know they're parallel yet, but okay. Yep. They're in corresponding positions, but I don't know they're parallel, so I don't know if those are congruent just yet. But yes, keep going. I think you're going to find it there. So these two are what? What type? A linear pair. So this one is 105 by linear pair postulate. Because these are in corresponding positions, and they happen to be congruent. Yeah. Then I can conclude that these are parallel by the corresponding angles converse. I like it. Wow. All right. Whew. I wasn't sure there. I wasn't sure there for a minute there. All right, let's look at some other theorems. Well, we don't know that yet. Yeah, I can only use what I currently know, but... Yeah, he would have gone here, and then these are... alternate exterior of one another, which is true. But we're going to, man, why isn't my undo working here? There we go. And then now that you know this, yes. So right there, Theorem 3.7, according to your Libro, yes, we would have been able to choose that route once we knew this, which technically right now, you're only believing this because a book published it, and I'm telling you that it's true. Man, I feel like, is there a line? Oh yeah, there is a line down there. That's not going to be lined up very well. Terrible. Nah, I'm gonna live with it. I know, yeah. It is frustrating. Arrgh. Alright. So guys, check this out. Turns out there's also the alternate interior angles converse, which, as you could guess it, if you can show that alternate interior angles are congruent, then the lines are parallel. So we would be able to prove parallelness using alternate interior angles. And hey, oh, well, we're at it. Also, yeah, we call this AIAC, maybe? Sure. And then this one, alternate exterior angles converse. Oh, man, if you could prove those are congruent, like Liam was just saying, then yeah, those lines, they're going to be the most parallel. And even if the way you could prove this is that vertical angles here and then corresponding angles converse there, right? So now you guys still might not be convinced of corresponding angles converse. Maybe we'll have to prove that someday. But we'll see. And then, so if I can prove these are congruent, wait a minute, no, these aren't congruent angles usually, unless they're both 90 degrees. These ones are going to be supplementary to one another. So if I could prove that consecutive kayak, if you will, consecutive interior angles converse, if I could prove that those add up to 180, then I can conclude parallelity, which is definitely a word. Like so. So guys, we're doing proofs today. Isn't it wonderful? Wonderful to do the proofs. Here we go. Let's look at example 2. Let's see. Proving AIAC. Prove that if two lines are cut by a transversal and the angles are congruent, then the lines are parallel. All right, let me draw my little two-column proof with my S's and my R's, my statements and my reasons. The gimme is this. Angle 4 is congruent to angle 5, is what was given to me. Given. Someone tell me what else is true. Vertical angles theorem. Yes. Yes. So these. Well, no, actually, this is where it gets a little weird. 1 is congruent to 5 by transitive. All right. And this theorem is then the lines are parallel. So my conclusion is going to be G is parallel to H here. And why is that true? CAC, right. So if I'm proving parallel lines, I'm using a converse. So on a test, if you said cat, I'd be like, no, right, and you'd lose. Oh, man, yes, I would have to throw that one in the dumpster. So yes, CAC, it's a converse that's going to prove the lines parallel. Ooh, man, example 3, picking it up a notch. Guys, are you loving proofs yet? You're loving it. If you're not loving proofs, by the way, you might be able to talk to my buddy Lauren from last semester. She said she found some YouTuber that was way better than me, that was able to explain it to her in every way possible, and she just like understood the universe as a result. And I'm just like, meh. Yeah. So you can go ask her. I don't remember who. I think they were from like the Midwest or something, and they were just YouTube mathematician experts, apparently, and I'm not good enough. Thank you. So anyways, in the diagram, R is parallel to S. So these lines are definitely parallel. Those guys right there. And angle 1 is congruent to angle 3. Those guys right there. All right. Ooh, trickiness though, huh? Ooh. Tricky, tricky. All right, we want to prove these guys are parallel. And we're probably going to make a mistake at some point along this. Let's see how we do. Let's start with the Givians. R parallel to S. There's a non-cursive R for us. The reason that's true is given. And I'm going to wait to say 1 congruent to 3. You could, if you were just looking to pick up points, you could give me all your givens at the beginning. But I'm going to choose this time to wait until it is convenient for us. All right. So, what's something we could say, do you guys think? I'm trying to prove these parallel. Right, we know that by given. I'm holding on to that. I'm keeping that card. Angle 1 is congruent to angle 2. And because I'm saying something about angles, it's got to be a theorem. And those are corresponding angles. And those are, in fact, formed by parallel lines, right? Yes. Yes. For instance, if there was an angle 4 up here, I could not say this yet because I don't know that these lines are parallel. All right, so it's a little tricky thinking about what we don't know, even though it looks like it's so. All right, so 1 is congruent to 2. What else? Oh, maybe now I could bring into play my angle. Angle 1 is congruent to angle 3. I'm thinking that's going to help us. Ooh, transitive property. What's the transitive property? Someone other than Emmett, since he suggested it. What would the transitive property say about these two statements? Equal? Yeah, angle 2 is congruent to angle 3 by the transitive property of congruence, technically. And what types of angles are those with respect to my PQs? And since I just showed that the alternate interior angles are congruent, the alternate interior angles converse. Man, we're so good at this. It's like we finish each other's reasons on theorems. Then what can I prove? P is parallel to the Q. Well done, friends. Well done. Excellent. All right, let's see. All right, here we go. I'm just looking at what I want to do next. And we're also going to do the patriotic example 4 in a moment. But first, check this out. How about this? If two lines are parallel to the same line, then they done be parallel to each other. So if P is parallel to Q, and Q is parallel to R, then P is parallel to R. All right. Well, but we didn't have a transitive property of parallelness until now. And now that we have a name for it, the topopple, I think, actually, no, I think it goes by T Popple, is at least what its self-titled album was. Yeah, T Popple, right? I think so. No? No. All right. But yes, this feels obvious. This is true, but now that it has a name, we can reference it as we need to, which is beneficial when doing other proofs. So let's see. All right, let's do example 4 for those of you who are patriotic, or I don't know, you don't have to be. All right. Feel free to like add some country song about like the American flag punching bad guys in the face or something in the comments below. I'm assuming that song exists. All right. Yeah, draw for me some of your best like fake made up alternative history and okay. So buff George Washington, arms busting out of his petticoat, bald eagle resting on his head. Okay, so yes, all right. I'm visualizing this. This is great. So our internet friends will submit their responses to Liam Math on top of the White House. Yes. Yeah. And then in the background is President Lincoln, and he's throwing like the alien spaceships from Independence Day, like he's like a discus, like like he's spinning around and he's throwing it because it was going to try to destroy the White House, but they failed. They did not expect Lincoln from the Lincoln Memorial was a robot designed to protect the White House. Okay. So I was just told that George Washington is eating a McDonald's cheeseburger while he's punching. It's supersized, and so his arms are super strong, but then also his belly is bulging out of his petticoat. Oh, he's okay. He's all ripped. Okay. All right. Okay. Man. Well, I love this alternating history that we are presenting here. But the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel. Parallel is the most patriotic way for lines to be. To the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Well, if S1... No, we don't. If S1 is parallel to S2 and S2 is to S3, then S1 is to S3 by the how now? Transitive property of parallel lines. Thank you for having the name right up there for us, too. So the T popple. Yummy. Man, I think popples, weren't those like the things in Futurama that were delicious, like little nuggets that you could get at the fast food restaurant? Yeah. Were they called popples? There you go. So T popples, there, represent. Man, true story. And eventually, T popple, I'd be able to say S1 is parallel to S13. I won't make us write all of it, but it's lots of T popples, right? S1 to S4 and S1 to 5, and therefore S1 to S5 and S5 and S6 and S1 to S6. Yeah, blah, blah, blah. All right, well, thank you for watching, internet friends, and please submit your amazing patriotic pictures, and I don't know, post them in the comments below.